Hello, can you hear me?
Yes, I can. Welcome, Alan. Sorry for the delay. Sorry.
Yeah, sorry, it was actually on my end. I thought actually the meeting was on a Google Meet link, and I went there first.
Okay, sorry about that. Okay, thank you so much for being available today. Thank you for being on this call. Okay, I think we just have 7 persons here, including myself. And okay, for the front end people on this call, please drop on your room to remind others. So we'll start in exactly a minute. So Alan, sorry if I'm not getting your name correctly. So start exactly in a minute. You can start off. So while we wait for others to join the call.
Cool. Awesome, I'm going to get started, and just a brief introduction of myself. My name is Alan Mugusu. I'm a software engineer based in Kenya. I work for a company called Yellowcard Financial, and I'm a backend engineer at the company. Been working there for 1 year now. Prior to that, I had a brief stint. I worked for 2 years at a company called Jacaranda Health, which is a maternal health care organization based in Kenya. We had about 1.4 million mothers enrolled in our systems that we were using there back then. And before then, I also worked at Andela and had with a few other startups. Then after that, a few other startups and all that. So in this presentation today, I'm going to take you briefly through MongoDB. But before we start, let me ask a question. How many of you have used a database before? Just feel free to raise your hand, react, chat on the chat there. How many of you have used a database before? I will start sharing my screen, but before then, I just want to know how many of you used a database.
Okay, sorry for the interruption. So please, for everyone on the call, you can drop your response on the chat. So we have a chat on this call. So please, you can drop your response. Thank you, guys.
Awesome. Am I allowed to share my screen? Could you please enable screen sharing? That would be helpful.
Okay, let me do that, please.
Okay.
Okay, Ms. Amaka, I don't know if you can hear me. Please, can you do that from your end? Thank you.
Cool. So I am going, okay. Wait, not yet, not been enabled. Okay, let me ask again, who has used the database before? I can't see anybody. Okay, I'm going to assume nobody has used the database before. Okay, next, I think, okay, can't see anybody. Okay. The screen sharing is still disabled, so I hope, I don't know who's the admin for these, they should enable screen sharing.
Okay, sorry, hold on, please. Thank you.
Okay. So I'm going to talk a little bit about what a database is. So since I understand probably none of us here has used a database, so I'm going to, waiting for the screen sharing to be enabled. But meanwhile, since no one is willing to talk, I'm going to point out somebody at random. Samuel Ayandare. I hope that's the correct pronunciation. So would you mind telling me give me an example of a database, and for example, what do you understand by a database? If somebody were to ask you right after you woke up, what is a database? What would you tell them?
Okay, Alan, please, can you try it again? Yeah, Mr. Maka, I don't know if you can hear me. So, Alan, can you try and share it again?
Yeah, I can. I'm going to share my screen, but I'm asking a question first. Does anyone here know what a database is first before we go into the introduction? Just want to gauge the knowledge levels of everyone. I know you know, just go ahead, just give it a try. Let's see. Going once, going twice. Okay, cool. That's fine. So I'm going to share my screen and then I think we can go through what these entails. So I hope you can see my screen, right? So
yes,
I'm going to share my screen and talk a little bit about what databases are. So according to Oracle, so I was doing my research and learning about the official definitions of a database is an organized collection of data that is stored electronically in a computer system. So if you've operated a shop before, or you've operated something that is transactional in nature, you know that these shops always try to keep a record of the transactions that have been made on that day, right? They keep a ledger or something of that kind. Then at the end of the day, you have to balance things out. You need to know how much came in, how much went out, and the rest of that. That is the manual process of it. Somewhere along the way, somebody came and said, you know what? We can actually build something electronic to do this, to organize this data for us. And that is the whole concept of databases. We can organize collections of data together and manage their access and control. So for databases, there is an access and control layer on top of them, which is called a database management system. So, and why databases are important? Why do we need databases? One, to store large numbers of records efficiently and easily. So compare this, for example, to the traditional ledger you have in a shop compared to the traditional shop. So you can see how quickly it can become unmanageable as the business grows. So let's say you opened a kiosk or a shop and you were serving 50 customers a day. You see, you can keep that in a ledger quite well. That's 1,500 in a month. That's probably manageable. But as business grows, you finally realize that, okay, you need an extra office because all these books are growing, they have all your records. And let's say a new customer comes and you want to see what was the transaction that they made, or how have they been buying and all that stuff. Let's say you need to do analytics on your data. You see that quickly becomes very inefficient. So one of the value of databases is it enables you to store these large numbers of records efficiently and easily, and also optimizes on your store. So imagine for, let's say, 1 terabyte of data could easily could be equivalent to a whole library in today's if I would equate it to what a business data store would look like normally. Yeah, right. So yeah. So and the other thing about databases is with databases we can easily sort information. So for example, you see with the traditional ledger, you may not be able to sort data by, let's say, created that you have to create a new ledger and do all that stuff. Let's say you want to sort maybe which products came in today, which products need updating, which products need X and X and X. So you see, sorting of that information becomes quickly difficult with a traditional ledger, but with databases, this is easy. And also for integration into other electronic sources. So, databases are the I would say the the back, or the, how would I put it, the core of most of the systems that you use today. So, and they are actually what enables integration with other electronic sources. So for example, you have your bank data being integrated with your with a mobile service, maybe your mobile service, a telecom provider, and all that. So what enables all that integration at the very core of it, while there are other layers built on top of databases and all that called APIs and the rest of that, there is at the core of it, you have databases. So, and that would not have been possible had we remained in the analog era with the manual ledgers. So, and finally, we also can have multiple people accessing the system at the same time. So this is not possible again with the ledger. You can imagine just having, a ledger where people, how would you enable access to all these people to the same ledger at the same time? And maybe you only want this person to view this part of the data and not to view the rest of it. That becomes a headache with manual ledgers, but with databases, this is actually possible. And security, as a result, is actually better. So let's see. Why? So what are the two types of databases? So broadly speaking, there are other types of databases apart from the two that we're going to speak about. But broadly speaking, there are two major types of databases. So there are relational databases and non-relational databases. Okay, so when we speak about relational databases, we mean data that is, the data in these databases is structured in the forms of rows and columns. So I think you have seen these. So when you have these data in a relational database, for example, examples are like MySQL, PostgreSQL, Microsoft Server SQL, Oracle SQL. You have data that has rows, data, the data is stored in forms of rows and columns, just very much like a traditional ledger. So for example, you'd have the name, age, date of birth, and the rest of that stuff. For a person, for an entity called person, you would have that. That will be the columns, and then the rows would include the data for each of those, for corresponding to each of those columns. So that's a relational database. So data is structured in forms of rows and columns. Rows are the data entries, and columns represent the fields of that data. So you can think of it like they are the attributes of that data, the columns, and then the rows are the actual data. That's where the actual data is. And then you have now the newer forms of databases, which are called non-relational databases. So non-relational databases are structured loosely. So the data is structured very loosely, and the schema is quite flexible. So they are very different from non-relational databases, because with relational databases, the schema is very fixed. So what that means is data has a specific structure in a relational database. It's very structured. It's in a table format. That's a relational data. Although nowadays nowadays we have they've tried to introduce some flexibility into it, but still relational databases require your data to be in a structured format. But non-relational database have a very flexible schema. So you can, and examples are, for example, DynamoDB, MongoDB, which we're going to explore today, CouchDB, and there are quite a few others. We're going to see why, for example, we have MongoDB and the rest of these, why these came up. Why didn't we just stick with SQL databases in the next slide? So, but before then, there are also other kinds of databases, which I thought it would be helpful for you to know. So there are graph databases that are coming frequently into use. For example, we have Amazon Neptune, we have Neo4j, etc. They represent data and their relationships with the graph of nodes. So these are still very new, and I think there's a lot of development that is still going on in this area, but I've seen quite a few job descriptions requiring you to have knowledge in graph databases. So it might be helpful as you explore NoSQL databases that you also try to understand graph DBs. Okay. So I'm going to move into the next one, and then I'll ask for questions. Okay. So how did the migration happen from SQL to NoSQL? So from the 70s, the SQL database is actually the technology that we have, the database technology is pretty much recent. It came up in the last 50 years or so. So we are really working with very recent technology in this space. SQL databases arose in the 70s because organizations had all these transactional data systems and they wanted a format to transact, to keep all this transactional data in their systems. And SQL databases quickly became popular because of their rigid schemas. It was easy for organizations that had transactional kinds of data and for relational data. So you have like in transactional data is mostly relational, and also just that kind of data became very, very, very synonymous with SQL databases. And because of also the SQL language, which is the standard, I don't know, is it standard query language or something? This is a query language built on top of SQL, of the SQL databases that made it pretty much easy to query or to retrieve data from SQL databases. So that was really helpful. But towards the late 90s and 2000s, there was a dramatic drop in data storage costs. So it became quite easy to store data storage. You see, data storage was very expensive in the early days of computing. So for example, if you go back to the history of computing, you'll find that those computers had like 128 KB of RAM, 120 KB of ROM. So you see, data storage was really, it was because RAM was really expensive. And for in those early days, for a computer that had 4 MB of RAM, that you had a very powerful computer in those days. So, but towards the late 90s and 2000s, with advances in microprocessors and advances in a lot of in data storage technology, there was a drop in costs of data storage, and NoSQL databases emerged. And the motivation for them was, one of them was the Agile Manifesto. So the Agile Manifesto was this document that came out, which was a proposal for building software quickly. And in this manifesto, the authors recommended that you need to iterate quickly in response to user requirements. And actually, if you look at the landscape today, most startups, they have actually adopted the manifesto. So most startups are using a version of Agile, Scrum, something, and they're often iterating quickly in response to user requirements. And this is across the stack. That includes the database. So that means that if you have a very rigid schema or a very rigid table, you don't want that. You want something that, let's say, you want to change these very quickly in response to user requirements. You don't want that to hinder you. So that really drove the adoption of NoSQL databases, which have flexible schemas and all. And then there was also a need to handle both unstructured and unstructured data. So think of it this way, towards 2007, Google had all these large data that was coming in there, these huge pools of data. And, most of this data is unstructured. These are the data that people are querying, and all this data is coming from everywhere. How do we handle this? And this drove the adoption of NoSQL databases, because with NoSQL database, you can handle both structured and unstructured data. And also, even in 2022 and even in the late 2010s, we've seen the rise of new technologies like IoT, which are kind of streaming data across the internet, and especially compared with cloud computing, distributed workloads across the internet. So all this data is just coming, and you have a lot of data that's unstructured, different structures. It's very difficult if you're going to start thinking about the schemas of all these data. You're going to start thinking about how to structure these data. So that is how NoSQL databases emerged as a really popular choice for computing. And also in the day-to-day with the rise of mobile phone apps and the rest of that, which are globally distributed, for example, you want workloads. So there is a need to intelligently geoplace data. So you might find a development team is based in Nigeria, but your users are in Russia or something like that. So you want a database which is quite performant for those users and which intelligently geoplaces data. So NoSQL databases provide sharding and these kinds of capabilities that allow you to distribute your workloads across the internet and place data in places where it's accessible to your users quite easily. So that's one of the reasons why people have been moving away from SQL databases to NoSQL databases. Okay, so let's talk a bit about MongoDB. What is MongoDB? Where did it come from? But before then, let me ask, are there any questions thus far? Before we go in, and then we're almost done, and then we'll go into the code. Any questions? Feel free to drop them on the chat. Okay. So I'll start with the pros. Okay, no, not the pros, but MongoDB. So again, MongoDB is a pretty recent database. It came about around 2007. So it's pretty recent, and it organizes data into documents and collections. So a document is, you can liken it to a record of data in a SQL database. So a document stores data in a BSON format, binary JSON format. And if you look at it, it looks like JSON. But the thing is with documents, the fields are you can liken them to columns of a relational database. So and then the values are the values could be likened to the raw values of a SQL database. And collections now contain a set of related documents. So you can have, for example, a collection called users, which contains documents, a document will be an individual person's details. Okay, so that's how MongoDB organizes its data. And the BSON format, why BSON? It allows MongoDB to accommodate more data types. And so you can have quite flexible data types there. And each document has a primary key identifier. So what that allows these documents to have is each document is unique because each document can be uniquely identified with a primary key. And Mongo Shell ships with the open source versions of MongoDB. So with MongoDB, there's a shell that allows you to perform database operations and maintenance. And I'll show you the shell and the rest of these other things, and to do maintenance. And it also uses a single master architecture. So architecturally, you have a single master that for data consistency, I presume that is where the writes are done. And then you have replicas that maintain copies of the primary. So you have a primary database where all the writes are done. So whenever a write is done, it goes into this single master. And then you have replicas which contain copies of your data. And operations are automatically replicated to those databases for failover. Okay, fair enough. Let's move to something else. So what are the pros and the cons? The pros of this database, one, of course, I've spoken about dynamic schemas. So you have flexibility in creating documents with any number of fields. Two, you have embedded documents, which you can embed like documents. So you can embed a document inside of another, and that eliminates the need for database joins, which in SQL databases can be expensive. So with this, you can have quite flexible, you have like quite, let me say it's cheaper to embed than to join in MongoDB. So, and the other thing is horizontal scalability, which I've talked about, sharding. So you can scale MongoDB horizontal. And so what that allows you to do, it allows you to distribute data across a cluster of machines. So with SQL databases, the way SQL databases scale is that they scale vertically. So if you want to increase the performance of a SQL database, you have to add RAM and CPU and the rest of that. But with NoSQL databases, you can scale them horizontally. You can add clusters of machines and the rest of that and distribute your computing across the cluster of machines. And the other pro is that you have aggregation capabilities because, Mongo supports MapReduce operations. So you can basically use MongoDB for big data operations. You can use it as a data lake for your operations, which are traditionally used for big data. So you see, this is a really powerful database. And also it's low cost. It's actually free. There's a free cloud offering, MongoDB Atlas. So it's free. So you can install it for free. You can run it for free. You can even deploy it. You can deploy your own cluster for free. Of course, you have to pay the cloud costs and the rest of that, but it's essentially free. You don't pay for the database like other databases like MS SQL Server or Oracle, which are not free. Okay, let's look at the cons. The cons, the data size is comparatively high. You have a lot of redundant field names. For example, think of it this way. So if you have a user data, you have a lot of redundant user data, like you have the field names are repeated in every document. So that's bad, but as you will see, as you can probably see, the pros outweigh the cons. And also the other thing is you have bad or inefficient indexing that can lead to very slow queries. If you do bad indexing with MongoDB, you can have very slow queries. And finding errors can also be quite time consuming. I've experienced this myself at some point. So, so you can, if you do bad indexing, especially if you have large amounts of data, you can have very slow queries. And the other thing is that, this is not really a con, but limited data size. A document can only be 16 MBs at most. That's the biggest size of a document, and documents can only nest up to 100 levels. But again, 16 MB is huge, you know. Documents can only nest up to 100 levels. That's not really a con, but yeah, if you have really documents which really need deep nesting, then you might be limited by MongoDB. And also joins, as I mentioned, are quite tedious. If you want to use MongoDB like a relational database, that may be quite slow for you. Cool. Awesome. So let's go into the demo. So I'll stop sharing briefly and then I will get, if you have any questions, just feel free to drop them on the chat. And then I will share my screen again, and then I will take you through a brief demo of MongoDB. Okay. I'll share again. So if you look at this, I have created a cluster, a MongoDB cluster. So actually, if you want to create, as I told you, MongoDB has a free cloud offering. So you can come and create your own cluster in MongoDB. If you go to mongodb.com, if you go to mongodb.com and you go into sign in or try free, you can go to try free and you can sign in there. And once you sign in, you'll be told to log into your account. If you don't have, you will be able to create one, and you can go around there and have your, and basically you will go through the process of provisioning a cluster. So a cluster again is, think of a cluster as your remote, where your remote databases will be. And if you look at this is in AWS. It's an AWS. It's deployed to AWS. So again, that is handled by MongoDB. So MongoDB handles the deployment for me, so I don't have to handle that, which is quite nice. And if you also see this is, it has a replica set of 3 nodes. So what that tells me is you have 2 nodes that are, so you have one primary and you have 2 nodes that are replicas. And then you have backups are inactive, so there is no backing up that's happening. And if you want to do searching on these, you can optimize, you can create a search index of these to optimize your searches and the rest of that. So if you look at this, if you click on the connect button over here, there are different connection methods that MongoDB offers. So you can connect to the MongoDB shell, and it actually tells you how you can go about this. So there are different operating systems that are supported. There's Windows here, there's macOS, and with this you can install the shell, Mongo SH, and then you can connect directly using this connection string over here. And the other way of connecting over here is you can come here and choose, you can connect with the Node.js driver. And again, you'll pass in this is the connection string, and you'll use that. So that's what we're going to do. I'll also show you how data looks like in collect. So let's browse collections. So we're going to look at how data would look like in a collection. So I have MongoDB locally here. So I'm going to, I'm going to open, yes. So I have some sample data here. I have some sample Airbnb data, listings and reviews, which you can actually, if you want this data, if you go to, okay, so you already have this data over here. But if you want this data, you could go to your cluster and then you can import this data. So the other thing is, if you want to try out MongoDB, one of the advantages MongoDB provides data sets, sample data set. So you can click on this load sample data set, and it will give you some sample data sets which you can use for experimentations or for demo work or the rest of that kind of work. Okay, so let's look at how this looks like. So we're going to look at some sample data. So if you look at this, this is a sample bookings data. I don't know what I did over here. Let's look at some sample Airbnb data, which has listings and reviews. And so you can see I have these documents, this collection of listings and reviews has 5,555 documents. And you have, the storage size is 51 MB. So you can see it's quite small. And if you look at this, you'll see something here. So you have this _ID property, which is usually the primary key of your data. So this is always unique for each document. So this is a document. This is a sample document. This is how a document looks like. So you have a sample listing would look like this. This is scrapped from Airbnb. So you have this is the ID, that is the name, this is the summary of that description. So you have the field and you have the value. And this is the data type of your data. So you can have strings, you can have arrays, binaries, booleans, chords, decimal 128. So you see we have supports for a lot of data types. So if you want to store integers, that's supported. If you want to store binary data, that's supported. If you want to store timestamps, object IDs, nulls, that is supported. Okay, and then if you look at these, you can even have nested. So there's a nested array here. So amenities is nested. So this listing has these amenities. It has a TV, cable TV, Wi-Fi, kitchen, all that stuff. And a host has this data. A host has a host ID and the rest of these. And again, you can see this data is actually even further nested. So you have like 3 levels of nesting. So, so you see, this is one of the advantages of MongoDB. So you can have really deeply nested data, and you have a field which has another nested field and the rest of that. And that could be helpful for you for some kinds of data, like this, for example, and all that. So what you're going to do now, so this is how a sample collection, so this is a listings and reviews collections. We can also look at geospatial data. So this is some geospatial sample data for shipwrecks. If you look at these has latitude and longitude data. And the ID for this is an object ID. And you see you have tuples, you have strings, you have integers, you have arrays. And if you look at this is also nested, and it's an array of the longitudes and the latitudes. So you can even store geospatial data in this database. Okay, so that's the sample data that we have. We also have restaurants and the rest of that. Okay, cool. Now let's, so MongoDB offers drivers, which you can use to access your data. So we're going to look at the Mongo shell. We talked about the Mongo shell, but let us now look at how you can actually use it. So if you look at this, I have opened the same data, but with locally you have the MongoDB Compass, which is an offline installer that allows you to access your cluster from your local machine. So I'm accessing the same data that I was accessing over here, but locally on this desktop app. So what I'm going to do, if you look at this Mongo SH. So this is the Mongo shell, and the Mongo shell is usually on the bottom left of your Mongo Compass installation, and you can open it. And if you look at it, there are a few commands which you can know. So for example, if you look at this, you can say show databases, and that will reveal to you all the databases that you have. So in this case, if you look at this, I have these sample databases. I can clear that, and then I can say show, okay, let me say show databases again. Now I want to connect to the Airbnb database. Say show sample Airbnb, no, sorry, show, I will say, not actually, if you want to use a database, or if you want to connect to a database, you use the use command. So you say use sample Airbnb, that will connect to, I'm already on that database, so I'm already connected there. So, and if I want to see the collections that are in this database, I can do show collections, and that would show me the collections inside this database. And so there's a listings and review collections. So I can come over here and say db.listings and reviews, if you see that. So in other words, I'm saying inside this database, or inside this database connects to the listings and review collections. And I want you to find one. So find one is used to find one document, a document that matches a specific query. So if I want to find one document, let's say we want to find a document with this name. So I'll come over here and say with a name is at Linda Vista Lagoa Rio. Okay, fair enough. Let's see if that will bring it up, and we press enter. And if you look at this, it's been retrieved, and you can see this here is the data. And you can see that's the ID and the rest of that. So let's say you want to find many, for example, let's find many which are in a specific, let's find ones that are in a specific locations, or which one bedroom houses, for example. Or wait a minute, let's find all rooms that are of property type apartments, all houses or listings which are property type apartment. You could do that. So I want to find all listings, listings and reviews. Find, it is find, so there's not find many. So think that's, so I'll just use the find command. So find, and you will say find where the property type, property underscore type is apartment. I'm just trying to drag this away. Property type is, okay. Let me just move it up there. Property type is apartment. Okay, what is happening? Okay, what's happening there? I just opened something else, but just open something. I just close that. Go back there. Apartments. Okay, let's see. So you see, there's quite a few of them, and it's going to filter and find. So this query is going to take a bit of time because it's trying to find all documents where the property type is an apartment. So this is a very long query. So you have all these documents, you have that, you have these, you have a lot of documents, and we actually don't want that. So I don't know if you can do like I don't know if you can count. I don't know if they still allow counting. Yeah, actually you can count, and if you look at this, you have 3626. Yeah, so you have 3626 properties or listings where the property type is apartment, and you can do this kind of thing, and you can do aggregations on this kind of data. Doobie.listings. So you can use these to do a lot of stuff, listings and reviews. Let's just run the previous command, but I want to do something different. So sometimes when you're debugging MongoDB, you want to find out why a query is slow. For example, you have this query that people are querying a lot. They're querying, okay, where is the property type is apartment. So you want to find, people are usually using this query, but for some reason, like we saw, it's slow. You can use the explain functionality to help you know the winning plan of your query. So I will explain to you what that means. But if you look at these, property type 1, room types 1, bed 1. Okay, this is actually doing, it's doing an index scan. So if you look at this, the winning plan here, if you look at this explain functionality, there's something here called the winning plan. So the winning plan is what MongoDB will use to get the most efficient way to query your data. It's the most efficient plan that will be used to get your data for you. So, so if you look at this, there's this stage called there's this stage over here called, the input stage is called this, it chooses the IX scan. So the IX scan, what that does is basically it's short form for index scan. What that means is that it's just querying using an index. I don't know if I should use, so if you look at this, we have a few indexes here, property type, room type, and bed. So let me explain what indexes are in a database. So indexes make queries faster. So they make queries faster by, how would I explain this? By making by creating small, by creating they create some extra memory in your database, and they store. So for example, if you look at these databases, if you look at these, they have 4 indexes, and this index is of say 65 KB. So what this does is that it creates some memory inside your database and stores that portion of data that you have said should be indexed there. And basically what happens is that when your query comes, it looks inside the index to find whether your data is in the index, and then it is retrieved quickly, basically. So that's a very basic explanation again. And I think you can dig deeper into how indexes work and the rest of that. But what you need to know, at least most importantly, is that when you add indexes to your data, indexes make your searches faster. So for example, you can come here and add an index. So you can create an index if you want to do so, and you can come here and say you want to index, let's say you want to index the amenities, and you want to create a text. Okay, this is, let's say you just want to create an amenities index and say amenities. Okay, so you could just create, you can come and create that index there. And if you look at that, it's a really huge index because there are a lot of amenities, there's a lot of data that has amenities. So you can think about having, so it's a huge index compared to the rest of these, because amenities is an array. So anyways, what I want you to see here is that you can explain data, and this is how basically you use the MongoDB shell and the rest of that. There are other functionalities you can do. You can show logs. You can come here and view logs of that database. You can show the profile. I don't know. Oh, okay, I'm not allowed to do this action now. So you can experiment with a lot of these with a lot of these commands and the rest of that until you get used to it. So that's it. And finally, because our time is almost up, I'm going to show you how to connect this on Mongo. I'm going to show you a simple project that how you can do this in code. So we can actually do this in code. So if you look at this, there's this MongoDB. So MongoDB provides a package called MongoDB again, which you can just install with npm install MongoDB. I just installed it shortly before this. So this is the latest, it's 4.9. And once you install it, I have added the database URI to the environment variables and exported it. There you have it. And so this is how you create a connection. So client is equals to new mongo.mongo client. So Mongo client is a class, as the docs say here, for making connections to MongoDB. And I have a main function here to connect to the client. And then I have a function here, just a simple function I created, find one listing by name. And if you look at this, I'm connected to the, so you say client.db. So this is the database I'm connecting to. This is the collection I'm connecting to, listings and reviews. And again, as you can see, the API is still the same. You're just doing .find one, and you specify the name and say name of listing and the rest of that. So if we run these, for example, let me run these. So not npm, but rather node index.js. If I run this, you can see, there you go. This is a sample listing. So that we have a sample listing in the collection with name Deluxe Loft Suite. That's what I was looking for here. So again, it's important to close your database connections whenever you open them, so that you don't have any leaks in memory, and you don't want leaks in your memory and the rest of that stuff. This is very important. Always close your database connections. Okay, fair enough. I don't know if there are any questions. This has been a very basic example. I had to rush through it, but I think you can actually access a lot more on MongoDB's website. They even have a course on it, so which is free. So feel free to go through it. Thank you. I'll share the presentation with you, and if you wish to look more into it, the better. I'll stop sharing and then take questions. Is there anybody who has questions? Go ahead.
Thank you so much, Alan, for the session. So for everyone on this call, please drop your questions on the chat. I think we have about 9 persons here for the students, yeah, currently on this call. So Anieti, sorry if I'm not getting your name. Bendex, Favor, J Flash. If you understood, please drop you understood every part of the slide. But if you don't understand, please indicate on the chat. So please start dropping your responses on the chat for the 9 of you on this call. Thank you. Okay, so there's no question like from everybody. So did you understand every part? So if you understood, just say I understood everything. I think it's just one person that just indicated. Yeah. Okay, sorry, Alan, you are muted. I can't hear you.
Sorry. Oh, sorry. Yeah. So you ask, so I'm going to answer the first question there. Can we depend on the database throughout the journey, or there are some exceptions? Yes, you can depend on MongoDB for most use cases. Of course, there will be some exceptions. There are places where other databases may be of great use. For example, PostgreSDB is really used best in transactional use cases. So in most fintechs, you will find that most fintechs that are coming up, which is where most people may want to work in, they are probably going to be using Postgres or a SQL database for that matter for storing transactional data, because SQL databases are built from the ground up to support transactional data use cases. So that's of course, MongoDB has support for that too, but most places it will be helpful to learn a SQL database as well as you learn MongoDB. So learn Postgres as you learn MongoDB as well. The other question, how do I connect MongoDB to Visual Studio? I think you can look, VS Code, you can look that up. Probably there is a connection, there's a tutorial for that probably, but I feel that there's a plugin for that. You can just look that up. Are there any other uses of MongoDB apart from structuring databases? Okay, MongoDB can be used for a lot of things. So for example, I was working for a health company, and most of our data was in MongoDB. We had a lot of maternal health information in that MongoDB, and we were using it for analysis and the rest of that kind of thing. So we're doing a lot of analysis. On top of that, we were building charts on top of MongoDB. That's something else I would want you to explore how you can actually build charts on top of data. So MongoDB has an analytics part of it. So you can do analytics with it. You can also do aggregations on top of it. You can use it as a data lake. Basically there are a lot of other uses for MongoDB. You can explore that. I believe you'll find more uses for it as you go along your journey. Cool. Anything else? I think my time is up. I'm supposed to rush into something else. Glad to have talked with you.
Okay. Thank you so much, Alan. Thank you for today's session. Okay, so I'm going to drop your LinkedIn profile here. So everyone on this call, please, you can connect with Alan via LinkedIn. And if you have maybe personal questions and you want to reach out to him, please connect with him via LinkedIn. So I dropped his URL link. So you take you directly to his profile on LinkedIn. So please, everyone, connect with Alan. Thank you so much, Alan, for today's session. Thank you so much for
thanks everyone. Thank you for inviting me. I really appreciate the opportunity to be here and for sharing.
Yeah. Okay.
Thanks.
Bye, guys.
Enjoy
Thank you so
yourself.
much.
Bye.
Bye. Bye, everyone.